this is Ladyada.
Hey everybody, and welcome to A Desk of Ladyada. It's me, Ladyada, here at my desk. Doing some camera engineering, but first up, Mr. Ladyada, is there any news or updates you want to tell people?
Nothing I want to talk about.
Okay, great. Alright, so I'm working on camera stuff. You can go to the overhead. I'll show off some of the cameras. So here is...
I don't want to focus on it. I don't want to
Well, this is the camera that I worked in on last week. This is one with the, the lens. And I showed off that I also had these samples that had a motor coil inside of them. We took this apart to show the coil inside. And then this has an autofocus capability, whereas this one, you literally turn this little knob thing to focus it. And I want to try to get the autofocus working because I thought it was kind of neat, but also I was kind of annoyed, like the Breakout board that I was using, which is, hold on, I have it here somewhere. Maybe not, but it was basically like this. Didn't work with the autofocus, and of course this is an open source, so it's like there's a schematic, but the schematic wasn't really clear, and like the pin numbering was wrong. But basically it looked like something was shorted, something, the pin for the motor was bridged on the camera Breakout. But luckily I'd actually been working on a camera Breakout myself, because there's a couple things that I don't like about the standard 2x whatever 12 pin or 8-pin camera boards that people sell. So I designed a simple Breakout, and I was like, well, this is a good excuse to get it together. So I put two together, and because the final two pins on the camera are that coil, and I think like every other Breakout like assumes like, oh, if it's not connected, we should just connect it to ground, which is, it's always like the conundrum, like you have a schematic and it says NC, and you're like, well, should I actually leave it NC or should I connect it to ground? In this case, most cameras connect it to ground, but I kept them floating, and so it was possible for me to red wire, connect this little wire here, which is the motor power, to 3 volts. I just made a little jumper pin on this camera Breakout, and so I got the... So then I was able to use the example code from the app note to do autofocusing, because you basically have to connect the motor power, and then you have to load firmware onto there's basically a microcontroller inside of here, a little DSP chip, and you load autofocus firmware on it, because the autofocus isn't built in. Why? I mean, whatever. It's kind of an add-on. It's an extra. Maybe by default it wasn't included, or maybe you want to put different algorithms in for how autofocus works. Either way, I found firmware around on the internet. It is a binary blob, but it's 4K kilobytes long. You slowly feed it into I2C, and then you can request an autofocus command over I2C from the camera sensor, and it'll do that little attempt to focus in and out until it's no longer blurry. So in the computer, this is the, can you?
Oh yeah, sure. Right.
On the computer, this is the Python code. So there's a file that, called autofocus.bin, and it's just like binary. There's no, there's no idea what it is. It's just some firmware format. In the code, you init the firmware by opening the file, and you load all that code into address 0x80, like one byte at a time over I2C. Slow, but it's effective, although I might try, I wonder if you can write 32 bytes at a time or more bytes at a time, because that would be, of course, preferable than writing like one address at a time. And then you can read the status at address 3029, and then there's commands to clear the autofocus and reset it. And that's actually, that's actually from the app note. There's an app note called, the embedded autofocus solution. And they say once you load the firmware, here's how you can trigger autofocus mode, and here's how you can request autofocus status. So it's actually quite simple. It's like the hardest part is just you have to make sure like you've downloaded the firmware properly.
But all this is closed source, and then you have to make some open source software to get it to do all this. Right?
Yeah, I mean, like the firmware that runs on the camera, I mean, it's like, I don't even know what it is, right? It's just a binary blob, and they're never going to release it, and so you can't design your own firmware. But that's not that unusual, and I don't feel like that's a reason not to use it. Cameras, normally the binary blob would just be built into the chip and you wouldn't even have access to it. So
yeah,
I think
cameras are one of those things, like we're coming out with an open source camera, but there's always like weird guts inside of a camera, just like there's BIOS on a computer. There's always something that we can't get everything, but we'll be able to have open source software for you to interact with this firmware blob, right? That's
I mean, you can still use the camera.
Yeah.
I mean, again, like normally, like I was actually expecting that the autofocus firmware would already be loaded in, and then you would still just send the commands. It's like I think they just want to make it so you can try different firmware blobs. But like, yeah, if somebody ever figures out what chip is inside here, you could probably reverse engineer it.
Decompile the binary, let us know, all that stuff to help out,
Okay. So given that, so this is...
Besides, you use Windows, so you'll never be open source, Ladyada.
Yeah, it's true.
You have, there's closed source firmware on the way up to your desk.
Yeah.
At work.
Yeah.
So you will never be open source.
Well, the camera you're using to film this is also
Will
closest
never.
memories.
Yeah.
So when you autofocus init, here I load that firmware file in, and it inits it, and then you basically just call autofocus, then that performs the autofocus mode, and of course you can ask for status. So here I've got, in my main loop, this is a main loop that captures a bitmap and then sends the bitmap to the display. So it's like a basic, blitter. And every 10 frames I'm going to run the autofocus. So let's try this. Oh. Sorry, rename the file. Okay, so now I can go to the overhead. So, so you can kind of see how I'm like pulsing in and out a little bit. That's the autofocus mode trying to autofocus. And if I put, well, it's kind of dark here. Let me see if I can, I can try to put some text in front of it, and it will, it'll autofocus onto the text. The thing that's, and this is like continuously autofocusing, and you can actually hear it click sometimes too. So it does work. There's also a special capability. There's a special mode where you can draw like a square showing where the autofocus zone is, because I think the different firmwares have different ways of like determining like where does it want to autofocus. Does it want to autofocus in the center? Does it want to like do like a square, like 4 signals? So there's like this one special capability where it kind of can like draw over the frame with the autofocus mode. So I might look at that next, but I just got this working. So that's good so far, and it means that I can start, knowing that and knowing the pinout it means that I can take this design that can you go to the computer? This design that was originally for the OV2640, which like doesn't have strobe and it doesn't have autofocus mode, and I'm going to redesign it for the 5640 as well. Like it'll still work for the 2640, but what I'll do is I'll connect the 2 pins here, which are usually data 0 and data 1. I'm going to have it so you can connect those to the 3-volt and ground line, and that way if you'd like to use it with autofocus mode, you can just like set a jumper. While I'm at it, I think I'm going to actually also put all these components on the back, because I really think I need a lot more capacitors. Like I noticed that the power supplies were like really like a little shaky, because like there's actually quite a bit of power being used. In fact, one of the things I noticed is that if I ran the demo for like, if I ran this like streaming image to TFT demo for a really long time, the camera actually like literally gets hot, which is surprising because it's only drawing like 150 milliamps. But it could be just like all that power is concentrated and it's not very well diffused. So the next thing I wanted to do is, in addition to this breakout, I wanted to make sure that this breakout could work with some sort of heatsink capability, to add a passive heatsink, not a motorized heatsink like a fan, but like a small passive heatsink that could maybe draw some of that heat off. I never saw this with the 2640, but the 5640, for whatever reason, this camera like uses quite a bit more current. When I looked at the, hold on. Yes, this is the pinout. So, hold on. That's the autofocus, and I think this had the register map, and at the very bottom, I just missed it. AC characteristics, DC characteristics. So, input high, hold on. Yeah, so this is like the current draw. And, it can get pretty high. It can get up to like 130 milliamps on the 1.5 volt DC power supply. So, I definitely want to have a heatsink for that. So I thought we could do that for the Great Search, where I tried to find a little heatsink for my camera.
All right, here we go. So just a heads up, we changed the Great Search music to be more retro-y, robotic sounding. One of our team members who is always doing our music, they just had a kid, so they'll be back soon. But that was courtesy of JP doing that roboticized version of From the Desk of Ladyada.
Thank you, JP.
The Great Search. I think it's a catchy tune because normally when you're trying to do electronics now, you're like, where in the world is that part I need? And then you think about The Great Search with Digi-Key. So that's where that song came from, and that's why we're doing it. And Ladyada, let's go to
a catchy tune you can hum while you're scouring for parts. So the part I'm looking for, just finished up a Desk of Ladyada where I talked about designing a camera breakout, and the camera module I'm using draws enough current that it actually starts overheating, and the heat affects the visual quality. So I want to find a small passive heatsink that I can stick on the back of my camera breakout, and what I'll do is the camera itself, is glued onto the PCB. So maybe you can go to the overhead real fast, and I can show. So you've got the camera breakout, and then the camera. There's a little bit of there's a metal body, and then there's this. I don't know if it's thermal, but it's like this very thin tape. So you remove this, and then I think this might be thermal. You remove this, place it in here, and then this PCB is going to extend a little bit farther. But now this is stuck onto the back here, and then over on the back of the PCB, I'm going to have a lot of vias through the ground plane, and then have a little heatsink on the back. So the heatsink, it's going to be, I think the largest it can be, it's basically between like 8 millimeters, and it looks like I can do like 10 millimeters. That's kind of, this is 10, so that'll cover it. I don't know if it makes sense to go much larger than 10. And I want something flat, rectangular with fins, and I'll try a couple. So there's the math behind it. You can calculate how much heat you're going to dissipate, but because it's going through a PCB with vias, really I'm just going to pick about a bunch of different heat sinks and try them all and just see which one works best. So let's go to the Digi-Key, and so search for heat sink. Take us to the heat sink category. So there's a lot of heat sinks. This category, it has 100,000 items. So there's a lot of different options. Let's start with just like active and maybe normally stocking, which is still 40,000 that are like available now. The next thing is there's all sorts of different types, but looking, I basically want something like this, right? This is a 17 by 17 millimeter, by 9 millimeter, and this is called a square with fins. And then this is like a square with angle fins. But I think I just want, basically square finned. So looking at this option, I think, rectangular is also fine. I don't want a rhombus. I don't want round. And then rectangular and square. Let's look at those. Okay. So that's like most of them, to be honest. So yeah, so like lots of things. These are the clip-on type, which I don't want. These go onto like a TO220 or something. They're really cool, but I can't use a clip-on type. So I want maybe one that isn't a clip type. But we can also do length and width instead. So remember, I wanted something between like 8 and 10 millimeters, and then this is between 8 and maybe I'll go up to 11-ish millimeters. And that really cuts down the numbers. There's not that many small heat sinks. Like again, most heat sinks are for large chips, but all these are really good. So like this heat sink, you can see it's this is 10 millimeters, I think. Sorry, this one is 10 by 10. This one is 8.5 by 8.5. So I might try like one of these and one of these. Of course, the larger the heat sink, the more heat you're going to dissipate. There's also like these kind of the mega longs. This I don't think is going to work out. Of course, it'll dissipate a ton of heat, but people are just going to knock this off of the back of the board. It has to be pretty compact so it doesn't like get in the way of things that are behind it. So I think what I'm going to do, especially since this one, there's 50,000 in stock and they're like 55 cents a piece. I think this one is a good option. This is 10 by 10 millimeters, 7 millimeters high, black anodized aluminum. It doesn't come with the thermal tape attached to it almost certainly, so that's something that has to be done separately. We stock in the shop, like you can just get 3M thermal tape and you cut a little square out and you put it on the back, and then that gives you a good attachment. You definitely want to use a thermal tape and not just double-sided tape because you want the adhesive to pass. You don't want it to be an insulator, right? Because the one thing you don't want is it to insulate thermally. So this one is the one I want. This is the Assman WSW Components V2017B. We have a lot in stock, so that's kind of like a good sign. It means I could actually like ship this with the camera breakout board and not have to worry about it going out of stock anytime soon.
And that's a great search.
That's it. That's my heatsink.
All right. So we'll see everybody during the week. Tuesday, JP product pick. Wednesday, we have 3D Hangouts, Show and Tell, Ask an Engineer. Thursday, JP's Workshop, and Friday, Deep Dive with Scott. In addition to Colin's Labs that come out on a Monday, Tuesday, Thursday, and Friday. And
there's something every day.
There's something every day. And then just today we posted up some of this camera stuff too on all the socials and more. So stay tuned for a big, exciting week here on
Moretronics.
Channel Adafruit.
Beep, 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 beep.
Okay, bye everybody.
Bye everybody.